conduct of this hearing. First, members and staff who are attending in person may choose to be masked, but it is not a requirement. However, any individual with symptoms, a positive test, or exposure to someone with COVID-19 should wear a mask while present. Members who are attending virtually should keep their video feed on as long as they are present in the hearing. Members are responsible for their own microphones. Please also keep your microphones muted unless you are speaking. Finally, if members have documents they wish to submit for the record, please email them to the committee clerk whose email address was circulated prior to the hearing. Good morning. Welcome to today's hearing on the future of weather research. Before we begin, I would like to take a moment to extend my sincere condolences to our colleague, Representative Sean Casten, whose daughter passed away yesterday. I'm deeply sorry for his loss, and my thoughts are with him and his family during this difficult time. I'd now like to welcome all of our esteemed witnesses to today's hearing in person after 2 years of virtual and hybrid testimony. Weather forecasting plays an integral role in society and a crucial role in protecting lives during extreme weather events. You may not realize it, but each and every American benefits from the federal investment made to support the National Weather Service every day. Whether you're using a weather app on your phone or watching your local meteorologist on the evening news, these products and services depend on federal weather data. Weather forecasting is consistently relied on to guide planning across the U.S., whether it's deciding whether to take an umbrella on a work commute, planning an outdoor gathering with friends and family, or determining a seasonal crop plan. My district has firsthand experience in the devastation that can be caused from extreme weather. The effects of Hurricane Sandy are still being felt by my constituents a decade later. The Hudson Tunnel remains compromised, and a project to rehabilitate the tunnel began only as recently as last year. While the Weather Service has significantly improved the accuracy of the hurricane track forecast since Hurricane Sandy, there remains a need to improve intensity forecasts as well. I'm looking forward to hearing from Dr. Scott Glenn of Rutgers University on how funding from the Sandy Supplemental was critical to his research to better predict and understand hurricanes, and why robust and consistent federal funding is necessary to support the transition from weather research to operations. When considering the future of forecasting, it is crucial that long-term forecasting is also part of the conversation. The Northeast Regional Climate Center reports that over the past 20 years, New Jersey has had an increase in extreme precipitation. The report further predicts that precipitation intensity will continue to increase in my district by up to 50% over the next 80 years, from what was observed at the end of the 20th century as a result of climate change. In a region that has seen the impacts of localized flooding events cause hard hits to homes and businesses, this report is alarming. Just last September, we lost 27 lives across New Jersey in the wake of Tropical Storm Ida. The sudden intensity and precise location of rainfall and flooding was difficult to predict. Emergency responders rescued people from roadways and homes where they did not expect flooding to impact them. I heard from a mother in my district who, along with her young children, had to be rescued from her home at night during Hurricane Ida. She said that she had been told at 5 p.m. that the storm would pass to the west. Empowering residents with accurate long-term and short-term precipitation models will give them the information they need when planning a move or a new business location or preparing for an acute weather event like Ida. Improving our understanding of precipitation trends and hurricane intensity is not just important for my constituents, but for all Americans. The accuracy of short-term weather forecasts in the range of a few days to 2 weeks has improved significantly in recent decades. However, there remain gaps in our ability to provide subseasonal to seasonal forecasts. Improved longer-term forecasts that are on the order of weeks to months would support the resiliency of critical infrastructure sectors like transportation, utility, and energy sectors that we rely on every day. To better understand what is needed to improve weather forecasting, Congress requested a report to identify necessary weather research investments. The Priorities for Weather Research, or PWR, pronounced POWER, report is a compilation of expert recommendations from across the U.S. weather enterprise made up of public, private, and academic partners. This report highlights the investments needed over the next decade in weather research, observations, modeling, forecasting, and dissemination. It takes into consideration how federal investment in weather research supports the private and academic sectors of the weather enterprise. We are fortunate that our witness panel today includes not only the co-authors of this report, but perspectives from across the weather enterprise. In the midst of another Atlantic hurricane season predicted to have above normal activity, accurate forecasts coupled with timely dissemination will be necessary to ensure the safety and protect the livelihoods of Americans along the Gulf and East Coasts. I look forward to hearing more from our witnesses today on how Congress can support the U.S. weather enterprise through federal investments in weather research that will benefit all Americans. The chair now recognizes Ranking Member Bice for an opening statement.
Thank you, Chairwoman Cheryl, and thank you to our entire panel of witnesses for taking the time to share your expertise with us this morning. Weather information does more than just help us decide how many layers to wear or whether to bring an umbrella. Forecasts based on accurate information are our #1 tool in protecting the life and property during severe weather events. That's extremely important because the U.S. experiences more extreme weather events than any other country. According to the National Weather Service, a typical year in the U.S. sees 26,000 thunderstorms, a few of which I see in my community weekly, 5,000 floods, 1,300 tornadoes, and 6 Atlantic Basin hurricanes. Luckily, academia, government, and industry have come together in collaboration to improve the timely delivery and overall accuracy of weather products and services. Collectively known as the U.S. Weather Enterprise, each sector, public, private, and academic, plays a critical role in understanding, observing, forecasting, and helping warn communities of danger. The largest improvement to weather forecasting can be directly attributed to both basic and applied research. Collaboration across the weather enterprise is critical to conducting this research and translating it so it can be successfully deployed on a commercial scale. For example, atmospheric data collected from a satellite needs unique computer modeling and processing power to be useful. And the final forecast or output product must integrate behavioral and social science to make sure people fully understand it and its impact. No one sector can develop or do all of this on their own. That's why transitioning research into operations requires buy-in and collaboration from everyone. It cannot be a competition amongst ourselves. To aid in our forecasting goals, there are countless emerging technologies that can and should be deployed. Automated surface vehicles and gliders in the ocean, drones in the sky, and advanced radar systems on the ground all have the potential to collect data that can supplement current federal efforts. Pursuing this research and subsequent commercialization will be invaluable to the U.S. and our communities. First, it will help us catch up to the European Union, which continues to outperform us with more accurate forecasting models. Second, it will support our economic growth. Essential pillars of our economy are dependent on knowing what the weather will be. For example, we need solar and wind data for renewable energy production, precipitation information for ag production, water management analysis for urban communities, and accurate predictions for road, marine, and aviation transportation. These are all areas of increased investment, and all of them require forecasts for safe and efficient operation. I can't think of a better panel to address this critical topic. We have representatives from academia, the private sector, and professional societies. I want to especially extend my warmest welcome to Dr. Fred Carr, a fellow Oklahoman and Professor Emeritus at the University of Oklahoma with the newly minted Women's National Championship softball team. Although I am an Oklahoma State fan myself, I will admit OU is widely recognized as a national leader in meteorology and has made vital contributions in this field. In fact, the entire state of Oklahoma has long been viewed as the center of weather advancement in the U.S., and I look forward to hearing how the National Weather Center in Norman is continuing to lead critical research and development. Again, I want to thank the witnesses for being here today, and I look forward to your testimony. With that, I turn the chair back over to Chairwoman Cheryl.
Thank you, and we are honored to have the full committee ranking member, Mr. Lucas, with us today. The chair now recognizes the ranking member for an opening statement.
Thank you for holding today's hearing on this important topic, Chairwoman Cheryl. Since I became the ranking member of this committee, I have time and again stated that the work we do on weather forecasting is as important as any topic before us. Protecting life and property, helping first responders anticipate maximum weather events, or ensuring that farmers and ranchers know when to best plant crops are only a few of the reasons having accurate weather forecasts is invaluable. And we can only have accurate weather forecasts if we continue to invest in resources and researching weather patterns. The ranking member of the subcommittee and I are both honored to represent Oklahoma, home to some of the most important weather research occurring today. The National Weather Center, located in Norman, brings together NOAA researchers, the University of Oklahoma faculty, and local weather forecasters under one roof. This collaboration is an important model for how NOAA research should operate. Additionally, Oklahoma is home to the nation's premier mesonet, which provides real-time data thanks to a series of small but powerful monitoring stations across the state. The mesonet has been a valuable resource for farmers, ranchers, first responders, and weather forecasters for more than 25 years. And I believe our mesonet should serve as a model for other weather observation systems across the country. It is with this background that I am proud to sponsor the Weather Research and Forecasting Innovation Act, more commonly known as the Weather Act. This legislation, signed into law by President Trump in April of 2017, was the most significant weather-related legislation to become law in 25 years. This legislation helped redefine NOAA's weather research priorities in recent years and also helped spur innovation by creating a pilot program which directed the utilization of commercially purchased data in NOAA's weather models. The Weather Act is due for reauthorization at the end of September 2023. Though that is more than a year away, I consider today's hearing to be a kickoff in our reauthorization process and encourage our witnesses to frame their recommendations with this in mind. In December of 2020, Congress directed NOAA's Science Advisory Board to commission a report on future priorities in weather research. This report, completed in December of 2021, utilized some of the finest minds across the weather enterprise. This report contains many recommendations, ranging from improving Earth system modeling to increasing NOAA's computing capacity. These recommendations should inform how we approach reauthorizing the Weather Act. Today's hearing is important because it provides a starting point for us in discussions about what areas where we have improved our knowledge of weather research, as well as gaps we need to address in the future. I want to thank the witnesses for sharing their expertise, and I look forward to a very productive discussion. And before I yield back, just a personal moment to share my sincere feelings with the chairman about the loss of one of our colleagues. And nothing can hurt more. And with that, I yield back, Madam Chair.
Thank you so much, Mr. Lucas. At this time, I'd like to introduce our witnesses. I'm pleased to introduce a fellow New Jerseyan, Dr. Scott Glenn, as our first witness. Dr. Glenn is a Board of Governors Professor of Marine and Coastal Sciences and co-director of the Center for Ocean Observing Leadership at Rutgers University. Dr. Glenn's research has focused on the development of remote and autonomous technologies for ocean observing in extreme environments, the modeling of coupled ocean-atmosphere systems, and improving the forecasting of hurricanes. Dr. Glenn is one of the NOAA SAB Power Report co-leads. Our next witness is Dr. Brad Colman. Dr. Colman is the Director of Weather Strategy for the Bayer Climate LLC and President-elect of the American Meteorological Society. At Bayer, he coordinates across multiple divisions to set weather priorities and works with scientists, engineers, and vendors to deliver critical environmental information across Bayer's global agriculture industry. Prior to joining the private sector, Dr. Colman had a nearly 4-decade-long career with NOAA, ranging from a forecaster to NOAA NWS lab director. Dr. Colman is also one of the NOAA SAB Power Report co-leads. Our next witness today is Dr. Frederick Carr. Dr. Carr is currently the McCaslin Foundation Presidential Professor Emeritus and Director Emeritus in the School of Meteorology at the University of Oklahoma. His research interests include numerical weather prediction, data assimilation, synoptic, mesoscale, and tropical meteorology, and use of new observing systems. Among his wide variety of professional activities, Dr. Carr was the president of the American Meteorological Society in 2016, served on the AMS's Executive Committee from 2015 to 2019, and is a fellow of the AMS in addition to currently chairing its Committee on Ethics. Our final witness is Dr. Kevin Petty. Dr. Petty is the Vice President of Weather and Earth Intelligence at Spire. Dr. Petty oversees science and engineering associated with the delivery of weather-related products and solutions, as well as the development of new observations that support our understanding of the planet. Before joining Spire, Dr. Petty was the Director of Science and Weather and Forecast Operations at the Weather Company, an IBM business. He has also worked as a project scientist and scientific program manager with the National Center for Atmospheric Research and senior meteorologist for the National Transportation Safety Board. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. Thank you to all of our witnesses for joining us today. And at this point, we will begin our first round of questions. I'll now recognize myself for 5 minutes.
I think witnesses need to give their opening statements first.
Sorry.
So you'll recognize.
So I'm going to recognize the witnesses in the order I introduced them. As you recall, you each have 5 minutes for your opening statements. So we'll start with Dr. Glenn.
Chairwoman Cheryl, Ranking Member Bice, Ranking Member Lucas, members of the subcommittee, I sincerely thank you all for the opportunity to speak today on the future of weather research and forecasting for our nation. My name is Scott Glenn. I'm a professor at Rutgers, the State University of New Jersey. And I was one of the co-leads for the NOAA Science Advisory Board report on the priorities for weather research, often referred to as the Power Report. The views that I'm sharing today are my own and not those of Rutgers or NOAA. The Power Report was produced by over 150 subject matter experts from across the weather enterprise. Through a consensus approach, experts from multiple sectors and disciplines came together to provide policymakers the information necessary to prioritize federal investments in weather research and forecasting over the next decade. Power is an urgent call to action. That urgency is driven by the increasing frequency of extreme weather events that cause hundreds of deaths and hundreds of billions of dollars of damage each year. It is driven by the need to develop a vibrant economy that leverages weather information into competitive advantages. And it is driven by the need to support equity and environmental justice across our nation. The Power Report responds to by documenting priority investments across the 3 pillars of the weather enterprise: observations and data assimilation, forecasting, and information delivery. These pillars are built on the strong foundational elements of the weather enterprise itself, the people entrained through workforce development, the high-performance computing for operations and research, and the world's best science. Taken together, the pillars and their foundational elements support our shared goal of a weather-ready nation. The results of the Power Study are 11 priority areas for investment, 33 recommendations and envisioned outcomes, and 102 specific critical actions to achieve these goals. Acting on these recommendations will be transformational for NOAA, the weather enterprise, and the people we serve. To illustrate how this broad range of recommendations work together to support specific needs, Power produced 5 narrative themes. One of those themes is high-impact weather. One example within this theme, the example I have studied my entire career, is hurricanes. Hurricanes are among the most destructive weather events on Earth. Since 1980, hurricanes have caused over $1 trillion in damage in the U.S., more than all other weather and climate billion-dollar disasters combined. In my home state of New Jersey, over 80% of the billion-dollar disaster damage was caused by hurricanes. Having lived through the intense winds and flooding caused by hurricanes Floyd, Irene, Sandy, Isaias, and Ida, I personally know the value of the good forecasts from our trusted National Hurricane Center. Through disaster supplemental appropriations provided by Congress that support hurricane observations and research, our science community has also learned what we can do to help make forecasts even better. Our team has pioneered new technologies for ocean observing in extreme conditions. We have used those technologies to develop a fundamentally new understanding of how the atmosphere and ocean are coupled and can rapidly co-evolve as hurricanes approach my home state. And we have helped transition both observation and modeling improvements into operational systems for NOAA, the Coast Guard, and the Navy. Fundamental to those advances is continuing NOAA's transition to an Earth system modeling approach. This will require observations of the atmosphere and the ocean below. It will require high-performance computing for operations and research, and it will require collaboration that crosses line offices and sectors. All of the investment categories and approaches are outlined in the Power Report. As one specific example, hurricane forecasting in the U.S. has long benefited from federal investments in the Hurricane Forecast Improvement Program. However, success is currently being limited, not by vision, but by support. In my written testimony, I've outlined 3 ways hurricane forecast improvements are being limited and what can be done about it. In conclusion, Power provides a framework for transformation. Trends in extreme weather events lend urgency. I urge this committee and Congress to act upon the recommendations outlined in the Power Reports that together we can build and able to serve the needs of our nation. Thank you.
Thank you, Dr. Glenn. Next, I recognize Dr. Colman for 5 minutes.
Good morning, Chairwoman Sherrill, Ranking Member Bice, Committee Ranking Member Lucas, and members of the subcommittee. Thank you for this hearing and for inviting me to speak with you today about the future of weather research and forecasting. My name is Brad Colman. I'm currently the Director of Weather Strategy for Bears Climate Corporation, President-elect of the American Meteorological Society, and co-lead with Dr. Glenn on the Power Report. The views I am sharing are my own and not those of Bear or NOAA. I want to thank the subcommittee for your support of the Weather Act and the NIDIS Reauthorization Act. These acts have been highly impactful and provide critical groundwork for many of the Power Report priorities. My testimony is based on 4 decades with NOAA, followed by nearly a decade in private industry. I worked across multiple levels at NOAA, from forecaster to lab director. At Bear, we, like many other businesses, leverage NOAA's array of products which supplement our own data and in-house expertise to serve our leading global agricultural business. I have seen NOAA's impact from the inside and out, and I have complementing perspectives of both its past and its potential future value. Today, we face sobering weather-related statistics. The nation is suffering from increasing billion-dollar disasters and the loss of hundreds of Americans annually, all despite continually improving forecasts and warnings. 5-day forecasts are as good or better than 3-day forecasts were at the turn of the century. Skill is now extending into the 2nd week. Hurricane track forecasts at day 5 are now as good as the 2-day forecast was just in 1990. The benefits to the public, transportation, and private industry are remarkable. These gains were not achieved through singular investments, major breakthroughs, or by a single sector of the weather enterprise. Federal investments have been instrumental, including the 88D radar network, next generation satellites, and the National Weather Service's Weather Ready Nation program. The academic and private sectors have made equally critical contributions. If done correctly, with planning and coordination across all sectors, the weather enterprise can extend its proven track record well beyond the next decade. I now want to discuss this core section of the report, Critical First Steps. This section lists 10 actions essential to the success of any comprehensive federal investment plan. They are a subset of all recommendations in the report and fall into one of 4 areas: research and development, infrastructure, actions and impacts, and NOAA prioritization and investment. The first area, research and development, includes Earth system modeling, data assimilation, and social and behavioral sciences. As forecasting skill has increased, a significant gap has grown between weather information produced and known by forecasters and what is understood and acted upon by public and emergency management communities. Addressing this gap is especially critical for historically underserved and socially vulnerable populations. Investments in this area need to be significantly increased in order to achieve the full benefit from other investments in the weather information pipeline. I do not have time to speak to the area of infrastructure, which includes data assimilation, high-performance computing, and Earth system observing networks. The actions and impacts area includes reanalysis and reforecasting, high-impact weather, and water cycle extremes. Reanalysis and reforecasting in support of operational numerical model development is critical, and it needs immediate attention at NOAA. In fact, the launch of their first Earth system model, scheduled for 2026, cannot be successfully implemented without this gap being addressed. The final area is NOAA prioritization and investment. At times, NOAA has struggled to align internal priorities and partner with external groups. This has likely reduced their overall impact. As such, increased federal investments in the NOAA National Weather Service programs would greatly benefit from NOAA having improved methods to assess, balance, and align these investments. Additionally, NOAA stands to benefit by increased partnerships with the broader weather enterprise. A strong private industry can provide value in the form of otherwise unavailable data, products, and services to federal agencies that in turn accelerate the overall research and innovation through partnerships, including with the academic sector. Successes in this area are wins for the weather enterprise and wins for the nation. In closing, this is a critical time. Our nation is increasingly challenged by weather extremes and climate change impacts. The benefits of executing a successful power plan will be transformational. Together, we need to build off past successes, learn from past challenges, and work together toward a better prepared, weather-ready nation. Thank you, and I look forward to your questions.
Thank you, Dr. Colman. I now recognize Dr. Carr for 5 minutes.
Thank you. Good morning. Chairwoman Sherrill, Ranking Member Bice, Science Committee Ranking Member Lucas, subcommittee members. It is an honor for me to testify about the future of weather research and forecasting for our nation. My name is Frederick Carr from the University of Oklahoma, and I speak to you today as one who has spent over 40 years either working to improve computer-based weather prediction models or advising NOAA leaders on how to improve U.S. weather prediction capabilities. While National Weather Service forecasts are of high quality and provide great economic value, these forecasts are not world best. Other global weather modeling centers produce greater forecast accuracy than we do. This gap shows that improved forecasts are possible and thus represents an opportunity for NOAA to serve the nation even better than it does now. How do we achieve this improved skill? The good news is that we can improve forecast of all high-impact weather phenomena: hurricanes, wildfires, flash flooding, severe storms, tornadoes, blizzards, heat and cold waves, droughts, by investments in 3 things. A, increased observations of the Earth system. B, development of Earth system models. And C, high-performance computing. Investments balanced across all 3 areas will enhance the skill of future forecast models, improve the guidance provided to weather forecasters, and lead to greater public safety and protection of the nation's infrastructure. Let's expand upon the needed investments. A, observations. First, we need to maximize use of underutilized observations to realize the benefits of investments already made. Second, we need to add observational capacity to increase the detail and accuracy of Earth system measurements. For B, Earth system model. An Earth system model is a sophisticated forecast system that includes not only the atmosphere, but the ocean, land surface, ice, air pollution, etc. The Earth system model is projected forward in time by supercomputers to produce weather forecasts and seasonal outlooks. Thus, we advocate that current models need to upgrade to Earth system models to enable more accurate forecasts on all timescales. Here are some of the investments needed here. One, accelerate development of Earth system models by supporting research on the physical interactions among all its various components. Two, use of Earth system models cannot be done without first determining the biases and errors in these models. This process must be done for all forecast systems. Three, develop improved storm scale models to forecast hurricanes, severe thunderstorms, tornadoes, wildfire evolution, and storm surge. And four, continue to invest in the Earth Prediction Innovation Center, or EPIC, to incentivize and support external partners to conduct research to improve NOAA's weather forecast systems. And C, high-performance computing. None of the increases in weather forecast skill over the past 50 years would have been possible without high-performance computing, or HPC. The weather community thanks Congress for recent HPC allocations, but there are still three problems. One, the allocations are often done via supplements and not via sustained annual investments. Two, research HPC capacity lags operational HPC, whereas it should be at least 3 times greater. And three, US HPC is still behind other global weather prediction centers. Thus, the following investments are needed in this area. One, expand HPC capacity by 2 orders of magnitude, or 100 times, over the next 10 years. Two, concomitant investments in storage, transmission, access, security, software engineering must also be made. And three, NOAA must prepare for future HPC architectures, develop a culture of rapid adaptation, and train a skilled workforce. Finally, I note that 6 Department of Energy labs have already acquired or soon will acquire exascale computing systems, each of which is 25 to 50 times more powerful than all of NOAA's computer systems combined. Why can't NOAA get some of this exascale action? Thus, we encourage Congress and NOAA to be more ambitious in enhancing HPC capacity in order to better serve the American public. Thank you.
Thank you, Dr. Carr. Next, I recognize Dr. Petty for 5 minutes.
Chairwoman Sherrill, Ranking Member Bice, and Ranking Member Lucas, as well as the rest of the members of the Subcommittee on Environment. Thank you for allowing me the opportunity to speak with you about what is a very important topic for our nation, priorities for weather research and forecasting. As part of my comments, I would like to share some high-level thoughts and perspectives on the priorities for weather research report. I would also like to highlight the role of the private sector in achieving the desired outcomes of the report. However, first, I would like to convey why this topic is so important to me. I have essentially spent my entire career working in the weather enterprise. I have held positions in the public, private, and academic sectors. During this time, I've endeavored to promote and contribute to research and development efforts that result in significant improvements in weather analysis and forecasting. However, on December 30th, 2021, this endeavor became quite personal. On that day, Colorado saw its most destructive wildfire in history, the Marshall Fire. The Marshall Fire, which was exacerbated by high winds and dry conditions, burned roughly 6,000 acres, destroyed over 1,000 homes and structures, and damaged nearly another 180, one of which was my home. We watched as entire neighborhoods burned to the ground in minutes, and to this day, my family remains displaced. Although we have made great strides in weather research and forecasting over the last several decades, there is still much to be done if we're going to prevent billion-dollar disasters such as this one. The Priorities for Weather Research Report is a timely, exemplary document that identifies and recommends investments designed to foster new and improved capabilities that can serve to reduce the number and severity of high-impact events such as the Marshall Fire. The report rightly expresses the fact that the scope of the investments necessary to support the advancement of weather for society is vast. Thus, it will be difficult for NOAA to make the material investments across all of the identified priority areas. Where it makes sense, NOAA should attempt to partner, not only with the academic sector, but it should also make use of the competencies and resources found in the private sector. As the private sector has grown, so has its ability to carry out rigorous, high-quality research and development. For example, Spire made significant investments that led to the successful deployment of one of the world's largest multi-purpose satellite constellations, with over 100 satellites operationally in orbit today. This constellation delivers a rich and unique set of data about the atmosphere and Earth. Spire is proud to be a Weather Ready Nation ambassador, and it is honored to be a supplier of radio occultation data to NOAA through the Commercial Data Program. None of this would have been possible without Spire's willingness to invest in science and technology research. NOAA is and will remain a cornerstone of the weather enterprise. It serves as a catalyst in driving research and forecast investments to mitigate the impacts of weather, water, and climate extremes. It is crucial that NOAA's investments are strategic, particularly from the perspective of ensuring that our nation is a global leader in weather prediction. Fundamentally, it is forecast accuracy and reliability that drive the effectiveness of downstream weather-related products, services, and solutions, including many offerings found in the private sector. NOAA should recognize and carefully consider its limitations and formulate a research and development investment strategy that includes clear trade-offs. As part of its efforts, NOAA would benefit from identifying and acknowledging the investments and contributions being made by others in the weather enterprise. It should not run the risk of replicating such investments, nor should it risk diluting its investments to the point that tangible and sustained progress in key areas is limited or negated, especially for core areas associated with forecast accuracy and reliability. This will require strong leadership and an organizational culture that embraces a more well-defined and focused approach. Most importantly, NOAA's ability to effectively respond to the recommendations found in the report is rooted in its ability to create strong, long-lasting partnerships. By doing so, our great nation will be able to recognize the full power and extent of the weather enterprise and what it has to offer. Thank you for this opportunity to share this testimony. I hope you found it helpful, and I welcome any questions or comments you may have.
Thank you, Dr. Petty. So at this point, we will begin our first round of questions, and I recognize myself for 5 minutes. Unfortunately, New Jersey is no stranger to catastrophic flooding events, as demonstrated recently by Hurricane Ida. However, large-scale events are not the only weather concern in my district. As I mentioned in my opening statement, the Northeast Regional Climate Center predicts that by the end of the century, precipitation will increase by as much as 50%. These changes in precipitation and area flooding are already being felt by the residents in my district, and I recently introduced the Precip Act, which passed in the House and will direct NOAA to update out-of-date precipitation data that can be utilized for decision-making in extreme weather events such as hurricanes, as well as for more long-term decisions such as buying a home in a flood zone. NOAA's Precipitation Grand Challenge aligns with this goal. Among other targets, it aims to update weather models to provide timely and accurate forecasts that can be utilized by citizens to make crucial decisions. Dr. Colman, as a member of NOAA's Science Advisory Board, you have experience with their weather modeling framework. How will investments into NOAA's weather research assist the agency in their work to update precipitation data and meet this grand challenge? What work do you see to be done in collaborating with other members of the weather enterprise to ensure that this data meets end users in a timely and accessible way?
Thank you, Chairwoman Sherrill, for the question. It's a complicated answer in my mind. The return frequency of events and the shift in probabilities of events as we move through this period of climate change are difficult to measure and really requires a collaboration across many different entities. Certainly, as we move into the next generation of models as Dr. Carr presented about Earth system modeling, one aspect of that is, in fact, the reanalysis and reforecasting piece, which I mentioned and how critical it is. That will give us insights into the distribution of events and the evolution of events as we move forward. So I think that investing in the model structure, but also it goes in statistics and how do you do the analysis and how do you attribute different events to different causes. Yeah, maybe I'll stop there.
Well, thank you, Dr. Colman. And Dr. Glenn, as a New Jersey resident, you are familiar with the devastation that hurricanes like Sandy and more recently Ida caused New Jersey due to extreme precipitation. How would advancing research related to the total water level support improvements to weather forecasting overall? How would the updates to probable maximum precipitation in Atlas 14 estimates, like what is included in precip and my Precip in the Floods Act, relate to this work?
Thank you, Chairwoman Cheryl. Total water level is the critical piece of this, because we see with hurricanes and storms, they're traveling slower. There's more rain involved with them. That warming ocean, there's more moisture in the atmosphere. And so improving all these models is one of the very important pieces of this. That improvement, over and over again, you'll see through the Power Report, comes through several levels. One is the observations that are made there to improve our understanding of the processes. Precipitation is a very hard process to forecast. It's like hurricane intensity. These are the two important pieces, the two critical pieces. How do we get the hurricane intensity right? How do we get the quantitative precipitation right? That's why there's those grand challenges. So critical pieces of that, especially for a place like New Jersey, whereas we look at the climate projections and we see that storms are going to be more slower moving, there's going to be more heavy rainfall, there's going to be stronger winds. So the stronger winds will produce more storm surge, the heavier rains will produce more flooding from the rivers, and so the combination of New Jersey being in the middle of that, you know, ocean water coming from the ocean side, the river water coming from the other side. So it's a very important piece to get the total water level right. In Sandy, there was so much of this discussion to figure out how much was from the ocean and how much was from the rivers. Thank you.
Thank you, and I'll very quickly, because I just have a few minutes, a lot of states are undertaking their own research initiatives, such as New Jersey's DEP. So, Dr. Glenn, can you comment on how regional climate modeling, like the efforts of New Jersey, can help communities and businesses prepare and adapt to the extreme weather impacts of climate change?
Sure. Thank you, Chairwoman Cheryl. The regional models that we are considering for the New Jersey area, the critical piece here is that the sea level is rising for many reasons in our area. We have the subsidence of the land, which is also very important, and plus that rise that just changes the baseline. And so that's very important for our area. The changes in the rainfall are very important, and the changes in the storm frequency are very important. So you consider those three pieces adding up together is an important part of this.
Thank you, Dr. Glenn. And sorry, I kind of cheated. I got you right at the end, and you didn't have as much time,
It's
but we
okay.
can also add some questions for the record. At this point, I would like to recognize the ranking member of the subcommittee, Ms. Bice, for 5 minutes.
Thank you. Several reports show that only a small fraction of satellite data we currently collect is utilized by forecast models. Dr. Petty, what are your thoughts on how we can extract more value from this significant amount of existing satellite data?
Thank you, Ranking Member Bice. I think that's an excellent question from the standpoint that as the report, which is an excellent report, calls out, we need to continue to do work on data assimilation. And data assimilation is a key aspect of how we gain an initial understanding of the state of the atmosphere. So as we forecast that atmosphere future in time or forward in time, those forecasts become better. through data assimilation and through investments of data assimilation, we will be able to take more and better advantage of those satellite observations. I will also just quickly add that as we move forward in time, there are opportunities to improve those satellite observations. And so as we identify gaps and determine how to fill those gaps, satellite platforms will be one component of that, along with terrestrial observations.
And when you say, when you talk about data assimilation, what is the best way to do that? Are you talking academia, private industry? What do you feel like is a good pathway for that?
Yeah, I think that pathway is across the board. The report points out some efforts to bring the community together through aspects of things like JEDI, which is a data assimilation initiative. Through that initiative, we're bringing the academic sector together along with the public sector and the private sector. Some people don't recognize that even in the private sector, there are teams doing data assimilation. So that's an opportunity as well to bring these scientists together to work on the best solutions.
Thank you. In the coming weeks, I'll be introducing a bill that codifies and expands the National Mesonet Program. The goal is to encourage and incentivize more states to build out or upgrade their systems so that we can have more mesoscale data across the country. Dr. Carr, given your familiarity with the Oklahoma Mesonet, how can more Mesonet observations supplement? Wow, I'm off today. Dr. Carr, given your familiarity with the Oklahoma Mesonet, how can more Mesonet observations supplement, improve, and add value to the satellite data we currently have? I think your microphone may be turned off, Dr. Carr.
I don't know if I ever had it on. Anyway, can I have the 5 minutes? No, anyway. I think that's a great question. I'm glad to hear what you're about to propose. I think we have 30-something states with mesonets now, all trying to match the gold standard that the Oklahoma Mesonet sets. So getting all the states on board would be great. I think the most important addition that we could add is to add to the third dimension to the Mesonet program. So they're starting now, but there's tens of thousands of surface measurements all over the U.S., but as soon as you go up 100 meters, there's almost nothing. There's 70 radius on, weather balloon stations. So we really need to increase the third dimension and add observing systems like vertical profiling networks to measure temperature, moisture, and wind in the lowest mile of the atmosphere. We call it the boundary layer. So increasing measurements in the lowest levels of the atmosphere in a three-dimensional way would be the most important thing we could do.
Perfect, thank you. As all of you know, NOAA is developing and releasing a user-friendly community Earth system model. There is also progress towards standing up the Earth Prediction Innovation Center, EPIC, which addresses the research to operations challenge by requiring NOAA to leverage expertise across the broader weather enterprise. How can capabilities like the community Earth system model and EPIC be most easily leveraged by academic institutions for research and education? That's open to any of you.
Yeah, I was very involved in the creation of EPIC, so it's got a great start. We have the Raytheon who got the first contract. They have a lot of task orders to provide computer support, move the codes to the cloud, provide user support. But what's missing in that contract is that we want the community and the private sector and everyone to be involved in improving the models, but there's no funding for this community. So Raytheon is doing its task on users and computer support, technical support, which is really important because we're short on software engineering that they have. But in order for the community to be involved, the private sector partners and the academic partners need funding to do the research needed to improve the models.
Thank you for the witnesses for being here this morning, and I yield back.
Thank you, and I'd like to bring to the subcommittee's attention a letter for the record from PJM Interconnection, LLC PJM, is the nation's largest regional transmission organization, responsible for ensuring the reliability of the high-voltage electric grid and planning the expansion of the transmission grid. PJM is regulated by the Federal Energy Regulatory Commission and serves all or parts of the states of New Jersey, Pennsylvania, Delaware, Maryland, Virginia, North Carolina, West Virginia, Ohio, Kentucky, Tennessee, Indiana, Michigan, Illinois, and the District of Columbia. This letter highlights the importance of NOAA's activities as a critical input to PJM's work in ensuring the reliable operation of the electric power grid. So without objection, I'm placing these documents in the record. Next, I would like to recognize Congresswoman Bonamici for 5 minutes.
Thank you so much, Chair Sherrill and Ranking Member Bice, for hosting this hearing, and thank you to our witnesses. We know that weather events are increasing in frequency and severity because of climate change, and in the past few years, Northwest Oregon has experienced lethal heat waves and devastating wildfires. We also continue to prepare for a potentially catastrophic seismic event off our coastline. I worked in the past with Ranking Member Lucas and others on the historic and bipartisan Weather Research and Forecasting Innovation Act, which is intended to improve weather forecasting and increase federal weather coordination. Dr. Glenn, how can improved weather forecasting prepare communities for severe weather events, and how can improved weather modeling deepen our understanding of the consequences of climate change?
Thank you, Congressman, for that question. So, how can we help the communities prepare? The third pillar of the whole weather enterprise was the information delivery piece of that. That's the critical piece that often gets left off the table, right? Many of the priorities come up at the beginning of the value chain, at the getting the data to improve our understanding, improving the model and all that. But then we have to communicate with those communities. And so we see how that's done in places like the Hurricane Center or something like that, where they have that trusted relationship with the emergency managers, and they have the ensemble of guidance that is guiding them. And so we talk to those hurricane centers, and they say, improve the accuracy of those ensemble models. That's the first step that you have to do. And so that's why you always hear us talking about that as that first step. And then that second step is building that trust with the emergency managers that have the real-time data coming in so they can choose, this is the ensemble piece, and then this is the piece that we want to communicate. And then there's all the research on how you communicate with those groups that has to be funded at some point so that we can understand their needs and bring them back. And that's how the requirements flow back through the whole weather enterprise. And so there's this important research on how we communicate, especially the new probabilistic forecasts and the longer-term forecasts.
I appreciate that, and I remember, and I'm sure Mr. Lucas does as well, all the conversations about the social science of communication and making sure that the message is clear and urgent. So Dr. Carr, your testimony and findings from the NOAA study indicate that immediate investments in our weather workforce are needed to fill existing gaps so that in the future, the nation can rely on a highly technical and diverse workforce trained in modern weather forecasting techniques. So Dr. Carr, what is the existing pipeline for the weather workforce, and where is further investment needed? What steps can we take to make sure this workforce can be effectively mobilized during times of crisis?
Okay, thank you for that question. There's a couple of aspects to that. One is that the research that we talk about that is needed also helps the workforce issue, so that the professors or researchers have graduate students, and these become the future workforce. So on something that's really technical like data assimilation, if we provide more research to work with NOAA on this issue and have more graduate students and postdocs, that will increase the workforce. With respect, we also, of course, need a lot of software engineering from the computer science component of universities in the private sector, and the issue there is they're very expensive for a government to hire. The private sector will always pay software engineers more. So we need a way for NOAA to have an entity like Epic that can hire software engineers maybe at the going rate and then help with the IT aspect of that problem.
Does anybody else have thoughts on how we can bolster the workforce? I have 30 seconds left. Dr. Petty.
Yeah, absolutely. I think kind of following on to what Dr. Carr has said, utilizing those funds to build partnerships. So for example, when I talk about the private sector is really looking at those partnerships. Hey, we can have interns who can be a part of the private sector and learn the technology, learn the research, so that we're working together to build that workforce. And I think that's an important approach.
Appreciate that. And as I yield back, Madam Chair, I just want to note as well the important issue of the high-performance computing. And I know this committee has worked on quantum initiatives and others that are so important to this issue. Thank you. I yield back.
Thank you, and I now recognize the ranking member of the full committee, Mr. Lucas, for 5 minutes.
Thank you, Chairwoman, and I'm going to address my question to the entire panel. As I mentioned in my testimony, this committee will be charged with reauthorizing the Weather Act during the next Congress. The report you've highlighted today will undoubtedly inform our deliberations as we think ahead on the topic. Given your respective roles in crafting this report, would each of you highlight one recommendation for this committee as we consider topics to address in the upcoming Weather Act? Just one, and I don't care who starts. And if we have enough time, everybody. Our way, gentlemen.
I'll be happy to start. My recommendation is found in the report, and that is enhancing our observations, particularly observations of the boundary layer. That's a critical component that we're missing as part of our data assimilation and our modeling to make our forecast better.
Dr. Glenn.
Thank you. I was also going to focus on observations. I think that's a critical part, the Earth systems observations. Many of our networks have been started, have demonstrated value, but they're incomplete, especially our ocean observing networks. And so completing the existing ones as we expand out to the new ones that are needed by the new Earth systems models would be what I would highlight.
Yeah, thank you for the question. As we try to point out in the report, we don't feel it's one simple answer. It's got to be across the whole board. Having said that, I will call out the information delivery piece. As I mentioned in my testimony, there is an increasing gap between what we're able to produce through the numerical models and what the forecasters then produce and send out than what people are getting and understanding. And we see that in day-to-day weather events where people take the wrong action. And we really need to put that investment into behavioral and social sciences up front and make sure we're getting all of the benefit from the other investments in the pipeline itself. We have underserved and vulnerable populations that different languages that do not currently get the right information and communications. We can't overstate the importance of making sure we complete that process so that they all benefit from the investments that all of you are willing to do. So.
Dr. Carr?
Yeah, so I'll speak up for the computing, because as we add more observational capacity, get billions more observations from satellites, which are already planned to go up as we increase the sophistication of the models and improve data assimilation and have more ensembles and increase our resolution. You can't do any of that without having the computing power necessary to accomplish it.
Along that line, Dr. Carr, continuing with you, and clearly it's a concern of several of us on this committee, how did the problem develop? Did we just not make the right investments at the key moment? How did we get to this point where we need to catch up when it comes to the computing power issues?
Well, that's a complicated issue. I think we've always been a little bit behind, and the procurement process takes a long time. So by the time you get a new system, there's always systems that are already 10 times faster. And maybe that is the way it is, but the Department of Energy somehow manages to get investments so that they can have exascale systems for at least 6 of their laboratories. And As I said in my testimony, I think we should be more ambitious and see if NOAA can become the seventh place in the country to develop exascale computing capacity. I think you just need to be ambitious and want it, as well as have the resources.
And I would note for the record, sometimes our questions may seem repetitive, but we as members tend to hone in on the information that you provide us. We're directed towards the points you make, and such as the computing issue, with additional questions, we tend to reinforce where as a body this institution needs to go. Your testimony matters more than you can possibly imagine on occasions like this. With that, I yield back, Madam Chair.
Thank you, Mr. Lucas, and I think we have time for another round of questions, so I'll recognize myself for 5 minutes. Dr. Carr, you talked about underutilized observations, and I wonder if you could go in a little bit into that. You also mentioned sustained versus supplemental funding. And it sounds as if, and Dr. Glenn could probably attest to that, a lot of the work we've done has been based on the Sandy supplemental, and now we have the Ida supplemental. If you could talk a little bit, and then if you want to weigh in, Dr. Glenn, about sustained versus supplemental funding, how the supplemental funding has impacted your research, but then the problematic issues related to not sustained funding. So if you could just start with the underutilized observations you were talking about, what those are.
Yes, so with respect to, there's two aspects to underutilize. One is there's a tremendous amount of surface network observations out there, and then a lot of them are not government. So there's this big effort under the National Mesonet program to try to gather together all of the surface networks that are produced by local and state agencies, and there's just thousands of them out there. So we're working to get.
So since I just have a quick period of time, so you're talking state and local organizations, because I know Dr. Petty also mentioned other opportunities, but my understanding is a lot of the private source of weather information is proprietary, and would that be more difficult to share with the government?
It could be, but it is being done. And so, I mean, in fact, the nation's lightning network is totally private, and NOAA buys those data. So the National Mesonet program is in the process of buying a lot of the surface data because they see that it's worthwhile. And then with satellites, as Dr. Petty mentioned, there's just so many instruments and so many channels producing so much high-resolution data. So every day, about hundreds of millions of observations are produced by satellites, maybe billions, but the models will use about 300,000 of them. So because there's so much, so we just have to learn how to better use them. And that's what we mean by better utilization of satellite data. And as we increase the resolution in our models, we'll be able to use more of it, and we need to have more sophistication in the data assimilation. And I think the other issue was
Funding.
funding. Yeah, the problem with supplementals is that they're great. They buy us new computers, but it's impossible to do long-range planning because we just don't have the annual appropriation is just too little to plan for a really ambitious, really ambitious computer power that we need. So it's basically a long-range, the ability to do long-range planning.
And Dr. Glenn, if you could talk a little bit about, because it sounds like the yearly is too little, what the supplemental enabled you to do as far as weather research.
I think the Sandy supplemental was an excellent example of how some of these things can get done. The Sandy supplemental replaced damaged infrastructure, 17 HF radars that were gone that we use for search and rescue every day off the coast. It helped with operations of getting our the gliders that Ranking Member Bice talked about out to sea. But what it also supported was the research that helped with the fundamental understanding that started this 10-year activity of working with the Hurricane Center and the groups like that got me here to this meeting today. It was through that Sandy supplemental that research happened. And that research is being put into operations now. The problem with the operational support for these new activities is that it is also in supplementals. And this year, we are in between supplementals. So that hurricane glider fleet that you were talking about is going to be much reduced this year when we expect an overactive hurricane season.
Thank you. I yield back. Ms. Bice, do you have any further questions?
One additional question. Dr. Carr, you are very familiar with the National Weather Center in Norman, Oklahoma. Since its opening in 2006, it has brought together all aspects of the weather enterprise, including NOAA researchers, faculty from the University of Oklahoma, local forecasters, and the Oklahoma Mesonet Office. How has this model of having different components of the weather enterprise under one roof resulted in better research?
Thank you, Ranking Member Bice, for that question. Yeah, so I obviously was very involved in the planning and building of the Weather Center, and we have about 11 weather entities in there, including the School of Meteorology, with its 300 students and 100 graduate students. And I think it's really beneficial for those students to be in the place where the weather knowledge is being put into practice in the Weather Service Forecast Office. And the building is designed so that with people can run into each other. The students run into people who wrote their textbooks. They run into the practitioners, the forecasters. They run into the research. They get to, and they have internships and student assistant positions. So it's just wonderful for our students, because I would imagine by the time they're seniors, probably over 75% of our students have some kind of student employment in one or the other, the Mesonet or the NSSL, and that's just a fantastic thing for our students.
And do you think this is something that we should be looking at more collectively as we look to the future for weather research, these types of models where you're bringing everyone together under one roof?
Well, yes. I mean, there is, I think there's a half a dozen other universities who are co-located with the National Weather Service Forecast Office. I would certainly encourage more of that. And anytime you have a NOAA laboratory, but they do have these cooperative institutes, and there's quite a few NOAA cooperative institutes that are co-located with universities. And so that model is working well. So I think we should continue to support our cooperative institutes.
Excellent. Thank you, Madam Chair. I yield back.
Well, thank you. Before we bring the hearing to a close, I want to thank our witnesses for testifying before the committee today. The record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. The witnesses are excused and the hearing is now adjourned.